All right, let's take a journey. We're going up, way, way up, into this invisible ocean of air that surrounds our planet. We spend our entire lives at the bottom of it. But what is this thing we call the atmosphere, really? Really?
Think about it for a second. Out there in space, it is just brutal. It's freezing cold, it's boiling hot, and it's flooded with deadly radiation. But down here on Earth, we're totally fine. So what's the deal? What's standing between us and all that chaos?
Well, the answer is both super simple and kind of mind-blowing. It's our atmosphere. It's this deep, layered blanket of gases, held tight by Earth's gravity, that turns our rock into a living, breathing world. And let me tell you, this blanket does so much more than just keep us cozy. It's got the oxygen we need to breathe, it acts like a planetary thermostat, and it's our personal shield against the sun's worst radiation. The bottom line? Without it, life as we know it just wouldn't be possible. Period. So, what's actually in this air? If we could just grab a big scoop of it and look inside, what would we find? Let's check out the recipe. The first thing that probably jumps out at you is just how simple the main recipe is. I mean, a whopping 99% of the air you breathing right this second is just two gases, nitrogen and oxygen. Everything else, and I mean everything, is squeezed into that tiny little sliver that's left over. Okay, so we all know oxygen is a big deal, right? We kind of need it to live. But nitrogen, the gas there's the most of, has this super interesting job. It doesn't do much on its own, but by diluting all that oxygen, it actually stops things from catching fire too easily. Without it, our world would be, well, a lot more flammable. Now let's talk about that tiny 1%. It might not look like much, but it is packed with absolute superstars. You've got water vapor and carbon dioxide, which are like the planet's thermostat, trapping heat. And then there's ozone, which is a special form of oxygen that acts as our planetary sunblock. And here's something that's just so cool. All the tiny, invisible dust particles floating around in the air, they're the unsung heroes of the atmosphere. They're the secret ingredient for rain, giving water vapor a little something to cling to. Oh, and they're also the reason we have beautiful blue skies and those incredible fiery sunsets, all from a little bit of dust. Okay, so now we know what's in the air. Let's start climbing. Our first stop is the layer we call home, the most chaotic, mixed up, and dynamic part of the whole atmosphere. Here we are, the troposphere. This is the very bottom layer, starting right at your feet and stretching up about 18 kilometers or 11 miles. We live our whole lives right down here at the bottom of it. Now, this layer is dense. It holds about 80% of the entire atmosphere's weight. And its name literally comes from the word for turbulence. And for good reason. Every single cloud, every storm, every gust of wind, it all happens right here. And you know how it gets colder when you climb a mountain? Yeah, that's the rule in the troposphere. The higher you go, the colder it gets. All right, let's keep going. We're going to punch right through all of that turbulence, fly past the highest clouds, and head into a completely different world. Welcome to the stratosphere. This layer sits right on top of the one we just left, and it goes all the way up to 50 kilometers. That's about 31 miles high. And this is where things get really weird. The temperature actually flips. It gets warmer the higher you go. So why is that? Well, this is the home of that all-important ozone layer. It's busy absorbing the sun's UV radiation, and that process heats up the air around it. It also makes the stratosphere incredibly stable and calm. And that incredible calmness, that's exactly why airplanes love it up here. Commercial jets climb up into the stratosphere to get above all that stormy weather down below and give us a nice, smooth ride. Okay, let's keep climbing. We're now entering the mesosphere. And if the last layer was the calm protector, this layer is more like our planet's cosmic shooting gallery. So the temperature plunges again, dropping to a ridiculously cold minus 100 degrees Celsius at the top. This is by far the coldest part of our entire atmosphere. And it's right here that millions of tiny meteors slam into our atmosphere and burn up from friction every single day, protecting us from space rocks and creating what we call shooting stars. Now, before we go any higher, let's just pause for a second. There's actually another way to look at the atmosphere. Everything we've seen so far, the troposphere, stratosphere, and mesosphere, is part of what's called the homosphere. That just means all the gases are mixed together. But above this, we enter the heterosphere, where the gases actually separate out into layers based on their weight, kind of like oil and water.
And we are now crossing that line. We're heading into the vast final frontier of our atmosphere, the place where it all starts to fade into the blackness of space.
This is the thermosphere, and the sense of scale here is just immense. It starts at 80 kilometers up and can stretch out as far as 10,000 kilometers from Earth. It's absolutely enormous.
The temperatures up here are, well, they're astronomical. They can get up to over 5,000 degrees Celsius. That is hotter than the surface of some stars.
Which, of course, brings up a really great question. If it's thousands of degrees hot, how come astronauts and satellites don't just, melt? And here's the trick. There's a huge difference between temperature and heat. Temperature just measures how fast particles are zipping around. And up here, they're moving incredibly fast. But the air is so thin. The molecules are incredibly far apart. So there just aren't enough of them to actually bump into you and transfer that heat. You wouldn't feel warm at all. But even though it's so empty, this is where so much cool stuff happens. The International Space Station and all our satellites, they orbit right here. This is also where charged particles from the sun create the amazing auroras. And there's even a special sublayer in here that bounces radio waves around, making long-distance communication on Earth possible.
So, what a trip, huh? We've gone from the ground all the way to the edge of space, from the chaotic weather zone to the freezing meteor shield to the super hot but empty final frontier. So after all of that, what's the one thing you should really take away from this? It's this. When you compare it to the size of our planet, our entire complex, life-giving atmosphere is really just this fragile, razor-thin film of air. It's a precious blanket that makes everything we know and everything we are possible.